start recording. Okay, I hope my computer is not going to die, because it's like a mini PC that I'm only using for Linux. All right. I'm going to show my screen in a second. Let's go to Excalibur again. Basically, I'm just probably gonna, for the most part, just do pretty much the same kind of walkthrough that I did last time. Just, I guess, a little bit quicker because I don't need to think about some of the individual parts. Also, hi, Paul. Great that you're here. We were just about to start. Let me quickly find the files that I've exported. Yeah, they're still here. Cool. And then I'm going to make another tab, open. Then downloads. All right, that looks good. How do I zoom? Okay. All right. Share screen. Then Excalibur. All right. Okay, so I shared. I always share specific applications. So if you don't see me do something, or it seems like I'm talking about another screen and not the one that I'm sharing, then please just let me know in case I forget to switch it. All right. So how to WarsWorld. So basically, let's just start with a top-down view on the project idea, or rather on the architecture of the entire thing. And this is the first of a couple of kind of what I call it, schematics or drawings or concepts, explanations, whatever, about how this entire thing works. So yeah, like ignoring some of the implementation details, like front end stuff and like some specific, this is like the general idea of how the WarsWorld architecture works, or should work in some cases where it's not like fully implemented yet. So basically, we have on the left side our players, how they interact with the system, and then our system is basically everything else, like in this box. So yeah, I said we ignore the front end, so that's why we have the back end here in the middle. So just gonna say that this is like our application code, like the WarsWorld code. And then here are a few things that our backend interacts with, basically any type of storage. So we have like normal memory, like RAM here over here. We have our database, and then we have the file system. So to start to understand why an architecture works in a certain way, we're just going to start by talking about the requirements. In other words, what we want to offer players, what players expect our app or game to do, and what a good experience would be like. So, of course, we have rather simple interactions like creating matches. So players would just like request, create a match for me, please. That would be a pretty simple thing. And then we have a lot more complex actions that involve a lot more logic, like performing an action. So an action is like one of the core ideas of WarsWorld from a technical side. An action is basically anything that you can do inside of a running game. So that would be moving a unit, creating a unit, ending your turn, triggering one of the two powers, all of that. Everything is an action, basically. And all of the actions have their own types by which they can be identified. And yeah, these require a lot more processing than something like creating a match, because in here where actions take place, that's where all of the game processing has to be done. So validating if a move is valid, doing all of the checking for hidden units, etc. That all happens when actions are performed. And then we have a third thing, and that also is very important to the architecture overall, and that's being able to observe games, both for participants, but also in afterwards when we want to view replays. So for both of these cases, we need not just a system that has a single state where we just have the current game state, but we also need a flexible way to be able to reverse games and view earlier parts and view individual moves in replays, etc. And so basically this first one doesn't really matter for the complexity and everything that we're going to talk about, because it's very easy to just create a match, like in general. Like how would you implement creating a match? You would have some sort of table on your database of matches that were created, and then you just add a row and you set some sort of state, maybe that you're still looking for players to play with. And other matches, maybe they have a state that they're ongoing, so nobody can join, and they don't show up in the table of open matches or something like that. So this is like pretty trivial, just as an example, and these two are where most of the complexity comes from. These are like the two actions that basically make up the whole architecture why we do what we do. So the thing is that in order to be able to have replays, we need a log of actions. And actions themselves, they don't have anything inside of them like RNG or if a unit got trapped. Obviously, because that's not for the players to decide, that's for the system to decide. So an action comes in and it basically the information that it contains is just the intention of the user. There are no damage values in there, because all of that obviously is calculated in the backend and not on the front end. Because otherwise, obviously, cheating would be very, very easy, because you could just send an action with bad data, and that would be very easy to do. So what we end up logging is not a list of actions, but a list of events. And that's what's over here. And in order to be able to provide replays, even during games and not just afterwards, obviously players would like to maybe be able, like for games that aren't Fog of War, you maybe would like to be able to replay the previous day of your opponent when you're playing a long-running game, like not a live game. That would be useful. If we wanted to implement that, I actually have no idea if Advanced Wars by Web does that or whatever, but you can like skip between days at least. I know that, and we need events for that too, or something like that at least. So events are basically the outcome of actions. So when you perform an action, some processing gets done, and then we have an event, and the event contains basically every piece of information of what happened in the game. For example, the event from the event we can derive the exact RNG values that were rolled. We can derive what decisions were made for superpowers that have randomness. For example, Meteor Strike. The event the list of events can tell us exactly what happened at which step. And so this is a piece of information or a list of information that we want to store in the database. And that's because we can't just store it in memory. Otherwise, the information will be lost if the application reboots or if it gets updated, etc. Or if it crashes, for example. So we write that to the database because database storage is persistent. Even when something goes offline, the data is still there when we start it back up again, no matter if it's like the database or the app or whatever. So that should be pretty simple and self-explanatory when you think about it. But the problem is that we can't only process our entire system based off of events, because in order to process actions, perform these actions. Like the event list is good for this, basically, for observing the game, obviously. But to process actions, we need to know the entire state of the match at the moment of processing actions. We can't just like look at all of the events and then construct a match again, basically, on every request. That would be extremely wasteful and probably way too slow. So what we need is a sort of server match state is what I've called. Maybe it's not a perfect name. Maybe we'll change the name at some point, but this is the best that I could come up with for now. And that's this thing up here, server match state. So we need the server match state in order to be able to quickly process actions, like checking where units are, if everything is all right with the instructions that the player gave, if the move is legal, etc. And the big question that we also talked during development about is where do we store the server match action for convenience? We could store it on the database, but then we have the problem if our database is basically our quote unquote source of truth about the match state, then we would need to contact the database on every action that is performed by the player. And for longer running matches with a lot of units, that could be also very slow in terms of performance. So we want to avoid going to the database every time to fetch the entire server match state. So what we do is basically we just store it in memory, the entire match state. So basically when we process an action, we read from the memory. And then when we have created an event in memory, obviously everything is in memory at some point. But our basically like permanent storage for events is on the database. That's where we put them. And afterwards, we can just discard of the event in memory. There's no concept in JavaScript of like freeing memory or something like that. If any of you have worked with system programming languages, basically we just take the event, we store it in a database, and then in our backend, we just kind of forget about it. We don't need to store it anywhere else. We don't process it anywhere else. And unless we do anything of this, we also don't need to read it from the database. And obviously, well, okay, there's one more part that we do for events, and that is, of course, we send the events out to all of the observers of the game with a little bit of extra processing, because obviously some events, maybe in Fog of War, we don't want to broadcast at all because maybe one of the participants doesn't see any of the relevant enemy units, or maybe we want to truncate the move path a little bit so that, for example, a tank that's driving through your field of vision, not field of vision, but your vision fields, we would only want to give the information like what was the last fog tile that it came like out of into the vision area, and which is the first fog tile that it goes into. We basically like cut off the path on both sides so that the client can never know the full path of the unit, how it traveled. That would be, I think, a very probably the way that Advanced Wars by Web does it, and I guess also how players would expect the system to work. So yeah, we store events with full knowledge on the database, and then we and maybe if there's like any sort of like hidden or secret information, we send out some basically like trimmed events down to all of the players. So I guess you could make this arrow like in reverse if you wanted. So now that we have our server match state, yeah, please ignore if I'm just pasting around stuff, because middle click on Linux, or at least on my installation, pastes text, and I really don't like that and do that accidentally all the time. So we have our match state in memory, and we have our events on the database. That's all cool. But the problem is, what happens if we restart the application? Oh, Jesus. So if we restart the application during matches that are still ongoing, we obviously need, we don't, this is lost because memory gets lost when an application restarts. So how do we recover from that? How do we prepare ourselves to be able to accept incoming actions and to process them? And that's basically where the recovery process comes from. I don't know if I have it here or here. I think it's this. Yeah, this is it. So basically what we do is, in case of any updates or server restarts, what we do is, before we start accepting connections, or even just like having the website open, before we do any of that, we first basically initialize our server memory and prepare it for the server match states to be in the state that they should have been, given all of the events on the database. We could theoretically also, like, every now and then write the server match state to the database as well, but then we have like the same storage on two sides. It just becomes a mess. It would be just way too messy. I think even though this is complicated, I feel like it's still the simplest solution to all of these problems. Otherwise, if you have a better idea, please let me know, because I would love to reduce complexity, obviously. So basically, the system I've come up with is that we have some sort of match, and basically the match contains information about what map is played, which would be this relationship, which players are inside the match. Don't think about the direction of these arrows too hard. Doesn't really matter all that much. The match has like all of the rules for the specific match. If there's anything specific, like if it's maybe like a custom match, maybe what kind of weather, or maybe if it's high funds or whatever, or that would be based on the league. It doesn't really matter, but basically it has all of the like initial information that is fixed throughout the game, or rather throughout the match. That's what the match contains. And all of this information is, when the match has started, it is static. It can't be changed anymore. And so our match, basically it points to the map, and the map has our information about all of the tiles, obviously, all of the changing tiles, so like pipe seams, capturable tiles, etc. And it also has all of the starting units if it's like a pre-deployed mission, pre-deployed map or something, or just like infantry for one of the players with a turn disadvantage or something like that. And so basically just loading the map gives us our starting state, which is like the same as you were just starting a match and none of the players have performed any actions. And so what we do during server boot up is we make one big query or a couple of big queries to load all of the events for all of the matches that are still ongoing, that are still incompleted. That we basically all of the matches that we want to populate our server match states with. And so we load all of these, and because we batch all of the individual events together, it's not super performance intensive because we don't need to go to the database a lot of times, just maybe like a few times to get all of the events. And then what we do is we use the same algorithm and functions that we use in our general match processing to apply these events to the starting state. So we take the starting state, then we apply the first event. So every event, when we generate it, has some additional code that will basically apply the event to the state. So if we have an event where we calculated some RNG and that a unit got destroyed, then we have some other code that will basically handle all of the events and apply them to a server state. So that would be creating units or destroying units. So basically the event has the instruction of what is happening. It's the log. And then that gets basically baked into the match state or like applied. And the match state is like this thing right here is just, you can imagine it like a big JSON object or a JavaScript object. Where all of the information is just, it is serializable as JSON. So it's not like a complex thing of classes or anything like that or functions. It's basically a thing that you can just serialize as is. It just has like static information. And so with all of these events, we just apply them in order until we arrive at the latest event that happened. So basically the latest action that a player took. And then what we end up with is that the server match state is just like before. we shut down or before we updated the app. All right, and so basically that's the recovery process, and I would say it's like one of the most important concepts about the technical side of WarsWorld. Do you have any questions for the system? This would be like our first chapter, I guess.
Did we touch on Filesystem?
I have you on max volume, but I still couldn't understand you well. I'm sorry. Can you come again?
Do you touch on Filesystem?
Yes, I was about to get to that, but for the serverMatchState and explain the events and how the recovery process goes, it's actually not important yet. But for the first presentation, that was basically just to illustrate the 3 possible storages that WarsWorld uses. So for Filesystem, I don't think there's any Filesystem integration yet, but basically the idea was that once a match has finished and there are no additional events coming in because the match is done, it's closed, then what we could do in order to not to keep so many events on our database, because obviously the events table will get very, very big over time, as you can imagine, because every single small action that a player does creates an event. So when many matches are going on, maybe possibly there are tens of thousands of events, or maybe hundreds of thousands, I don't know, depending on how big the player base is, could be in there. And obviously it can't grow forever, it would just become too big. So the idea was that at some point we would basically take all of the events and then put them together into one big JSON blob thing, and then write that onto a sort of file system. And it could be the local file system on the actual server that we run, or a local development machine, or it could be a more a better suited type of object storage, which is a term from cloud computing. What's a conventional file system, if I just write to my C drive or something, that would be known as block storage, where the application has direct writing access to individual parts of the storage. So I could read the start from a file, I could read the end from a file if I wanted to. It doesn't really matter. I have low-level access. And then there's a second type of storage that is used in web services and cloud, which is object storage, where you read and write data using HTTP, using a web protocol. And you can't partially read and write data. You can only read and write whole files. That has the advantage, though, of often being a lot more performant, because you can sort of proxy files directly to users, but I'm not going to get too technical about that. But the most important part is that object storage is often a lot cheaper than block storage, because it can be on slower storage tiers, like hard drives instead of SSDs or something like that. And especially for large amounts of data, it's a lot cheaper. And luckily, we don't have a use case where we need block storage, because we just want to write whole matches or read whole matches. So that's basically when we would take a whole bunch of these events, put them into one file, and then write them to some sort of object storage or local file system or whatever, and then we could remove them from the database. And in our database for the matches, which are not, obviously matches are also stored on the database, but we would go to the database and then say, okay, for this match, you don't have events on the database anymore. Now you point to this file on this object storage if someone wants to view the replay. Yeah, so that would be basically storage explained. It all starts with data, basically. Any questions?
Oh. Yeah. Go ahead. You can go first. I asked earlier.
So this starting state on the second slide, basically to the right, is it from the start of the match, or say from the start of the turn or so? Is it on the order of hundreds or thousands of events to be applied, or only 0 to a few dozen?
Definitely hundreds, depending on how long a match goes, or thousands rather, I would say. Maybe even tens of thousands. So yeah, it's a lot. So the starting date is always the start, the very, very start of the match. And yeah, I know that there could be concerns for how computationally expensive this is. And there are some ways to help with this. Later on, we could employ a strategy where we basically sort of take snapshots every now and then. So basically we create server match states that we store on the database, but they are like from different points in time, like every couple turns or something like that, or every turn. But that depends on how it's going to work out for performance. But for now, we're just going to do it the simplest way.
More question on applying the events to the starting state. So it's just going to be like incremental updates to the starting state, right? So unit moves left, it's basically starting state plus movement to the left.
Yes, you can imagine it like a fast forward. I don't know if any of you have played a game like Heroes of the Storm. I don't actually know if other MOBAs do it the same way. But when you play Heroes of the Storm and you watch a replay and you want to jump to the middle of the match, it actually has to fast forward through all of the beginning because it doesn't store the whole state at every point in time, because that would be wasteful and not performant and way too big. So it only stores the individual instructions that lead up into this point. So that's why it has to like go through everything in order to get to that state. So it's basically the exact same system that we employ here.
So basically each so E1 and E2, they're just basically their own individual event, and they just accumulate.
Yes.
All the way up to En.
Yeah. Yes. Ideally, I don't think it works out exactly, but for the most part, every action creates a single event, and every event is related to an action. But there are like a few exceptions. For example, random weather changes would be unique extra events maybe. Or maybe we would just tag that onto the ending my turn event. We would just combine that. But there's like some potential room for events that aren't related to player actions.
Okay. And I am assuming there's sort of be like just an extra, well, it doesn't go along the chain, but sort of merge into the chain, I guess, of events. Like weather events, I'm guessing.
Sorry, I didn't really understand.
Or maybe like what you said about like random game events. So you have this chain from the starting state to the end of the game, right? So random events will just be like separate parallel lines that merge into the events.
Well, we don't have. What kind of random events are you talking about?
Like you mentioned earlier about like weather.
Weather, for example. Yeah. So it isn't set in stone right now. Like I said, theoretically, random weather is always connected to the end of a turn. There isn't any random weather that just happens on its own, right? It's always still connected to a player interaction. And so therefore, theoretically, we could say, okay, when right here, the player performs the end my turn action, then we process it and see, okay, it's an end of turn action. And if the match has the information that there should be random weather, then we just basically, when creating the event, we say, so this is the end of turn event. And also let everyone know that now, so basically just informing the players through this observation that now the match is raining. Or now it's like raining and stuff like that. We could just add that to the previous event.
Okay. So it's like so assuming we talked about that. So I guess like E1 to E2, and let's just say we turn on random event and it gets triggered on turn 1. Then basically it just applies that state in E1 before it goes to E2.
Yeah. Yeah. So
Okay.
so weather changes would be on the same event that end of turn is.
Okay.
Anything else doesn't really make sense. But theoretically, if for some reason it was more easy to develop, more comfortable for some reason, then we could also just say, okay, we create an event for end of turn, and then we create another event for weather change. Would also be possible. But like, I don't really see a reason why we would need to do that. I think it would just be easier if we keep if it's possible, we keep the rule intact that every player action creates a single event and every event is caused by a single player action.
Okay. All right.
Okay. So talking a little bit more about events, just to kind of illustrate more about what's happening and the difference, because it, like, when I talk about it, that actions and events are like, have this one-to-one correspondence. It seems like they are like kind of linked together, or they should be related on the database or something. But the thing is that an action is always a temporary thing. It just comes into the system. It's a piece of information that comes into the system, gets processed, and then we forget about it. We don't need to store actions because we have the events. And so an action gets into our system, and then on our server, we create the event by employing two more pieces of information. And one of them is server-only knowledge. And that basically means the client, the player, basically doesn't know where hidden units are, for example. So when the player or the client sends an action event to move a unit, when we process it, we need to look at our server-only knowledge of hidden units, or maybe fog of war, etc., to maybe change the path that the unit moved and stop it at a certain point, and then add some information. Okay, this unit got trapped on this tile. And also, obviously, RNG processing. So these are like the two big things that go into the processing or into the generation of an event. And when we are done creating the event, then we send it out to observers participants. And actually, I should probably add a third here. So actually, let me think about it. We actually do this in a certain order, and I should probably do this here as well. So this is what we do last. I already know that much. Yeah, I'm pretty sure we do persistence first, because the first thing that we want to do is store to the database so that it's basically safe, quote unquote. And then what we do is we apply to serverMatchState. And I'm gonna upload these files to the channel at some point, or screenshots or something like that.
I want to ask a question first.
Yes.
So will we not apply, like, persistence and serverMatchState should be flipped, or we should wanted to make it persistent first before applying state?
I'm sorry, I can barely understand you because of the volume.
Oh, sorry. Do we want, because the server match state basically is the whole match state, right? So do we not want the event to apply it to the match state before get it into before making the data persistent?
That is a good question. That is a good question. But if we apply it to the server match state, and there's a problem when writing it to the database, then effectively it only lives in the server memory from that point on. And obviously, like, if the database has an issue, then before we like broadcast the event to observers and participants, we would like show an error or let them know or something. But I guess we could talk about that, but maybe not right now. Maybe unless maybe you have some more points. But honestly, I just picked it because it felt right to like store it first, have the information be secure, and then apply it to the server match state, and then broadcast it.
Just in case there's some type of server error that occurs.
Yeah. Yeah, like if it crashes, then a unit, because you need to keep in mind, maybe a player was counting on a certain RNG, and then they got this RNG. And like theoretically, I could explain that some other time. Theoretically, every move, like if it doesn't work, or the player, or the like, if we process an event and for some reason the server dies, like at this part about right here, before we like store it, the next time that we process it, like when we restart the server, the outcome should actually be the same. And that's because we're using like a sort of, or at least we want to use a sort of like deterministic RNG, where the RNG is based on the current turn, or like the current action. And that's also why we don't need to store the actual, theoretically at least, we don't need to store the actual RNG values in the event, because we can just derive them from what event number this is. It's basically our sort of like seed for the RNG function, in addition to another seed that's like truly random that we roll once, because otherwise, obviously, every move would be predictable when players figure this out. So we have like, for each match, we have a sort of like a seed that's stable for every match, but only the server knows about that until the match is over. Then it becomes public as part of like the replay. And yeah, then we use basically the starting number together with the event number to be able to process the RNG stably, repeatably for every event. But yeah, that's also already like a kind of technical side, but yeah, it like in theory, I think it would absolutely work to switch these around. But maybe there's like some implications about that. I'm not too sure. That just felt right to me.
All right. Yeah, I was just a bit curious about the ordering, but yeah, it makes sense to have persistence first. Like, yeah, I can see that,
because like if we have a problem here, then we can still recover because we still have the event on the database, even though it should theoretically we should be able to like repeat the same event given the same action if the player just repeats it. But yeah, as soon as we store it, we are basically on the safe side of we have the information. Depending on how we use that, that's a different topic, obviously. But theoretically, like if the server dies here before it like finishes to apply it, and then we restart, then it will basically do this step again because of the recovery process that we describe here, and then it should theoretically work. Or not, because we have a bug in our system that will always crash, but then obviously like it's a big bug, right? Okay.
Yeah.
So yeah, that would be the core concepts in terms of business logic on WarsWorld. Any questions up to this point? All right, then we're going to move on to the second one. Oh, it just loaded. Whoops, it just loaded the same thing on both tabs. Okay, give me just a second. I will load the right file. And I will quickly store this as well. So save to disk. This is like WarsWorld dev slide 1. And now we're gonna load the second one. And this is where it gets messy. Just as a heads up. Share screen. Excalador. Am I still recording? Yeah, seems to be good. All right, so this is the second and more messy slide. So now we get into the actual technologies that we use for WarsWorld. So I find it easiest to go from right to left, even though I go from left to right in terms of front and back end. That just kind of seems like sense, because we read from left to right, and that's also like how on a technical view we go from the client or player browser, which is like for this explanation it's all of the same, to the back end, to the database on the right, and then maybe back again if we read any data. But yeah, on the right we just have an SQL database. That's basically the database that I've talked about before just now, which stores the list of events and match data, etc. Yeah, and then we have this big thing, which is our basically our entire application. And it has some parts that are like exclusively front end, exclusively back end, and some things, as you can see here, that are like some kind of in between, a little bit of hybrid. Yeah, and then we have our client, player, browser stuff. So front end world, everything that basically runs to the left side of this line is something that we consider to run on the browser, and everything on the right is we consider to run on the server. And everything that doesn't cross the line is exclusively to that side. So for example, we have our pixi.js rendering code, which is basically the thing that renders the game board, nice and visually and with good pixel sizes, etc., good filtering. None of that runs on the server in any capacity. And then we have things like our WarsWorld main logic, which would have our game processing, game logic that for the most part runs exclusively on the server side, at least from the perspective of just providing the game service. There's some stuff that I could also put on the left side. For example, we have things like damage calculations, obviously. And damage calculations, the cool thing that about us using Node.js, so basically JavaScript on both the front end and the back end, is that we can share code. We can reuse the same code on the client and on the server to provide different features. So obviously, if we have a function like calculate damage that like takes into account the terrain, the unit types, powers, and RNG, that is obviously useful for our backend because that's what we use to calculate damage values and to see if a unit got destroyed, etc., and set health points. I think that is very self-explanatory, but we can reuse this same function, the same piece of code on the front end for the damage calculator. So, but the important piece is that it's not technically like the same code when it runs. It's just like a copy that got sent to the client that it can also use for calculations. So we have basically some shared code, and that becomes more apparent in the file structure when we look at the project in a bit. But that's like one of the exceptions that is not really shown in this diagram right here. Yeah, and then we have a couple of technologies that kind of like cross this boundary a little bit. And I will get to that when we work a bit through this thing. So at the very end, quote unquote, of our stack sits a prisma, which is an ORM, which is an object relational mapper. It basically allows us to interact with our database without having to write raw SQL statements. That's like generally the main purpose. But what it also does is it not just saves us from having to write raw SQL all the time, but it also has a layer of type safety. So as you can see at the bottom here, the TypeScript is like our entire foundation, and Prisma is set up in a way that it provides type information for TypeScript or for us to use in a way that is consistent with the database. So basically, if you've worked with other programming languages, like maybe in Java or PHP, maybe you do something like you write a class that describes one of the tables on your database. So the class would have all of the properties of the columns on your database with the appropriate data types. And then maybe you do some additional logic to handle references between tables, like joins, relationships, one-to-one relationships, many-to-many relationships, etc. And in some programming languages, you manually need to keep these classes and interfaces in sync with the database. That would be a very simple approach. That's luckily not complex. It's very easy to understand, but the problem is that it's not maintainable. It doesn't, when we change one of the two things, we need to go by hand to the database and then change columns, or we need to go, if we change something on the database, we need to go into our code and change properties there. And it's just, it quickly becomes a mess. And an ORM generally solves this problem by having some sort of system where we can define a schema or like a set of classes, and then the ORM will make the database adhere to this system with some restrictions. Some actions Prisma can't figure out how to properly communicate them to the database, and that's where migrations come in, but we're not going to go into detail on that. But generally, Prisma will give us objects to work with and also make sure that the database has the right columns and tables for us to work with. So yeah, if you've seen anything like, I don't know, players.findAll, this would be like an interface or a code that is generated by Prisma, for example. So all of these like very easy database interactions are what Prisma allows us. So we use Prisma for reading from the database and writing to the database. So for example, when we process an action, we don't need to look into the database at first because we have all of the state in our memory. So we just look in there. But as soon as we finish creating an event, then we use Prisma to write it to the database. And for example, if we load the list of matches on like an overview page on WarsWorld, we use Prisma to look into the database, find all of the matches corresponding to the filters that we want, and then we have that list of objects and we can send it to the client, or rather respond to the client's request and then send it back. All right, then directly interacting with Prisma is our WarsWorld main logic. That's all of most of the code that we write. And yeah, it basically is our business logic. That's where all of the fun stuff happens that I talked about before: processing matches, logging in users, listing stuff. Yeah, basically most of the important stuff happens in here. And this is the part that you would find in every application, obviously. Like the main business logic is what it's generally called. So in front of that we have tRPC, and tRPC is what is basically a sort of smart router. I need to take something for a second. So I'm just gonna use my Express example again. So maybe some of you have seen or worked with Node.js before and maybe started to write a small web server. And if you do that, you would most often come across Express, which is a web framework. I would rather call it a library, but I'm not going to get into a discussion about that. But basically, it's a node module that allows us to very easily create a web server. And with these very, very basic components, we theoretically can create pretty much any website, web service, online multiplayer game, whatever we wanted. Because all we need to do is like basically all of this code. That's all. We can just copy this, put it into a Node.js file, install Express, which is just a single command, and then we would be good to go, and we would have this feature where it responds to any requests on Stash and sends back hello world. So how this works is basically we initialize an app, which is just calling this Express function right here. We specify a port that we just give to the listen function later on, and then we register a route here. And we do that by calling get post or whatever method we want to allow on this route. We specify that as like the function that we call here, the specific method. And like this, it's important. This doesn't trigger a get request. This basically registers a route for handling get requests on this path. And then we have this function expression. And it's a function that we, as the developers, supply to Express, which Express will then call whenever these conditions are met for an incoming request to our application. And then we can handle it here. We can send back data. We can look into the headers that the client has sent, etc. And we could do that with post and put and everything, and then we would have a full big web application. So why am I talking about this? I'm talking about this because this specific way of being able to write a web application doesn't get us any type of information about our backend in a TypeScript kind of way. Because when we just call app.get, that's just basically it's like an instruction of registering something. But in terms of our code, before we would deploy the application, we can't really like generate a sort of schema from this. We can't look into all of the routes that our app has. I mean, theoretically we could, but it would be very, very messy. And yeah, I don't think anything like that exists for Express. And that is where the big difference with tRPC comes in. So I guess while Express is considered a web framework, I would say that the most important feature of Express is basically the routing. And that's like this type of stuff where you don't have a single function that gets called for every request. Instead, you can define different routes, like the /login handles logins and /user sends back user information from the database, etc. And that's what we call routing. We route incoming requests to different parts in our application to decide what to do with it. Or rather, the decision on what to do with it is basically the routing. And then we just run the code from the relevant route. And so what tRPC does differently is instead of having this be like imperatively, it is descriptively. It's kind of hard to put into words. And I think you will understand when we look into the code a little bit later on. Maybe just so this would be the demo of tRPC, and there's a lot going on, but the important part to take away here is that on the left we have our server code, so this is like kind of switched around from the diagrams I've shown you before, but the important part is that we have a router on the left side, and we have our consumer or client on the right side, where we basically, it looks like we're calling backend functions directly, which is generally not a thing that you can do. But tRPC lets us get very, very close to that, because tRPC works by defining objects instead of calling instructions to register routes. We basically have information about all of the things that our backend can do, and the required arguments and the output, and all of that is collected in a sort of oops, didn't mean to jump down there. All of that gets collected in this app router thing right here. This app router thing right here, because we are creating an object here, has all of the information about our backend, what it can do, what routes it have, what are the requirements for the different data types, what can we pass. And so this is a piece of information where we can use TypeScript to basically take this type data that only lives in our IDE, like inside the TypeScript world. It doesn't live in the deployed world. That doesn't matter. And we take that into our client through some actually not that quirky tricks. And then we can use helpers that use this type information. That would be this helper, for example, this create tRPC proxy client. We pass in our app router the thing that we exported here. So we're taking an exported type from our server side and import it in our client. And we are allowed to do that because it's just type information. It's not actually like any JavaScript code. And then the tRPC client is configured in a way where we get autocomplete and like hinting and linting and all that good stuff for when we write our front-end code. So a common problem that we would have in front-end development is that we always need to jump back and forth between our server code and our front-end code in order to see what routes do I have, how do I contact them, what data do I need to send, is this data correct, is it the right shape, the right data type. And tRPC basically solves this issue because we get type information directly when we write our front-end code. That's the important piece in this. And all that is only possible because instead of writing it like this, we write it like a object definition, basically. Just with some extra pieces here and there, but you don't need to worry about it. That's like the general idea. So tRPC is basically our router, which decides for incoming requests which parts of our logic handles them. And these basically are our WarsWorld main logic, because of tRPC, is split into what I call procedures. So basically, tRPC doesn't call them routes, it calls them procedures, because there are good reasons why they are called differently, but for any web developer that knows what routes are and how they work, basically with tRPC, we call them procedures. That's the gist of it. And an important part is that because we have the requirement of being a very interaction heavy game, and we want to be able to send players the information of what's happening very quickly. We don't want to have players have to refresh their web page in order to see what's happened. That would be the old Advanced Was by Web, if anyone still remembers that. I actually never seen Advanced Was by Web with refresh less, I think. But that was like a big thing that they introduced actually not too long ago, where you could actually see the moves as they happen from the player. So how does that work? There are the important piece is that generally, when working with a web application, you can only send some data from the client to the server, and then the server can respond to that. But when that's done, when that has happened, the connection is closed again. And the server can't send any information on itself to us. It can't initiate a connection. And that is a very common problem. And one of the common solutions is using something that's called polling. So polling would be that we basically, in our client code, we say, okay, just ask the server every few seconds about any updates. And that actually works pretty fine as a general technique, but the problem is that it's very overhead heavy. There needs to be a lot of stuff happening to create and close the connections all the time. It's just a lot of redundant work. So how do other video games do that? Just like something like, I don't know, CSGO or Overwatch. So what they do is they don't use any of this browser web technology. They just keep a TCP connection open, which is TCP is just like a lower level of how internet works, basically. So they have they keep a connection all of the time open. Actually, it might not be TCP, it might be UDP, but that doesn't really matter for this explanation. They basically just keep sending data all the time, and the applications are written in a way where that is possible. So how can we do the same? How can we enable our server to initiate sending data to our client without the client doing anything? Because obviously, when a player performs an action, they initiate the request, of course, but all of the other participants, they don't initiate any requests because they don't know when exactly the other player is going to perform that action. So they need to be notified. So how do we do that? Basically, there are two solutions for web-based games like the one that we're writing here. Or rather three, I would say. One we already covered, which is polling, it works, but it's not super efficient. The second one is not very popular yet, but is very promising, and maybe at some point we want to use it, which is called server send events. And the last one, which is probably the most popular one to solve this nowadays, is WebSockets. And so WebSockets is a different kind of connection. It's not HTTP, it's its own protocol, which is abbreviated to WS or WSS for secure connections. And it keeps a connection to the server open so that the server can send data back. And so tRPC has some documentation on how we can make it use a WebSocket link, and that allows us to do things like subscriptions, which would be basically the client initiates a request and keeps a tunnel open to our backend, or not a tunnel, but a connection open to our backend. And then from our backend, we can, whenever we want, send data back. That would be like a normal subscription. And all of the clients that are subscribed to this are called observers. And sending data would be called emitting an event. And so that's how we get this very ideally super fast two-way communication between the client and the server. It also actually helps in the other direction when we send data, because we don't need to initiate a full request, but it's not super important for that. So that's why we basically say tRPC, we wrap the entire thing in a WebSocket link. And there are different links. By default, we would use an HTTP link, where any sort of subscription would have to be polling based. But yeah, we use a WebSocket link instead. So all of the actions are go through WebSockets, and I think right now we only use WebSockets, but it would probably be smart if we kind of like split tRPC a little bit, and for all of the match routes we use WebSockets, and for everything else like the starting page, news, chat, etc., we just use regular HTTP just to keep it a little simpler and a bit more concentrated on what solves which issue. Okay, so basically that's everything that's truly relevant for the backend, and now we get into the slightly front-endy part. So we use next.js, and next.js is a meta framework, which is very, very buzzwordy. But basically what next.js does is it allows us to create a front-end application and handle a lot of things that you would typically have to manually set up with something like React. So React itself is like front-end only. It doesn't have any front-end routing. So we have actually two different sets of routing in our application, and that's very common. For the backend, routing means an incoming request to basically relay that to the correct part of our code that we want to execute, or the correct function. And for our front end, routing means calling different components depending on the URL. So when someone goes to /user, they get the user component loaded. And when someone goes to /home, they see the home page. So that would be the routing part. And Next.js helps us with that because of file-based routing. So if we wanted to create a new route on the front end, we just basically have to create a new file, and we don't need to register the route in any sort of list or something, or any sort of index. So that's one of the things that Next.js takes care of. It also does a lot of other stuff. It already has things built in, like being able to import CSS directly into JavaScript, and many other things as well that make applications more performant and kind of easier to manage. But that also means that Next.js itself bears the load of all of the complexity. So that's why it's like kind of a bigger thing on this diagram, because Next.js itself is actually very, very complex because of all the things that it does. And it tries basically to lift all the complexity that otherwise we would have to do manually from us and do it for us. So that's like the kind of idea. And one of the important pieces that or features that Next.js has is server-side rendering. So the thing with front-end development and using React to be able to easily build a front-end application is that normally we would only have a single-page application. So when we request the website, for example, let's just say we call /matches. Let's ignore the game part for a second, because it doesn't really matter for this explanation. When we load the game list, the server, if we didn't have Next.js and just use regular React with whatever kind of other tools that we needed, it would only send back a very small piece of HTML that basically has like some of the generic information about the website, that the title is WarsWorld, and maybe it already loads like some CSS. And then it just has a couple of lines of HTML, maybe like the body element, and then some kind of extra empty shell element. And then it loads a script tag. And the script tag loads all of the JavaScript code that we generated that contains all of the React code and our own code and like Tailwind classes, etc. The problem with that is that if we want to have good integration with services like Discord or Twitter, these services, when they try to load a website to generate a preview or a title, which I think you all know, they don't run any JavaScript code. They only look at the HTML that they get from the server, because running JavaScript is very expensive on their scale. They don't want to spin up a sandboxed browser to process all of that. So by default, if we didn't have Next.js or server-side rendering, we would just see generic titles, no previews, no map previews, no images, nothing, because all of that would only come into effect once JavaScript is run, and a lot of those services don't do this. And so to solve this problem, what we can do with Next.js is Next.js has server-side rendering. And so what we can do is in our routes, we specify some information that gets kind of like loaded in a sort of special way by Next.js before any of the front-end code runs. And actually, before we send data even to the browser, it will do some processing on the backend side. For example, it can go through our tRPC and logic stack to the database and fetch information about the map that's being played. And then maybe we can do in our WarsWorld logic, we can generate a preview for this map, which of course we should cache and stuff, but that's not going to get into that. And but you can like imagine like a nice preview and of course fetching the title of the match, like maybe which players are playing or something like that. And then Next.js can generate HTML from our React code on the server and puts data in there, correct data, like actual real data. And that is very similar to how web developers used to develop applications when we didn't have front-end frameworks, when we were just using server templates. Like maybe, for example, you've heard something like, let me think, like Java time leaf, or maybe PHP with their Blade templates when you use Laravel, or maybe you've used Django, which also I'm pretty sure has their own templating language. It's basically just code in order to generate HTML, but on the server. That's how we used to write web applications. And but the problem is, if we only do that, then we don't have any interactivity. And our game needs a lot of interactivity. We want to open menus and pop-ups and calculators and chat messages and all that stuff. So it does make sense to still be very, very client and browser heavy. But Next.js kind of puts it both together, allows us to render information that we want to work on clients that don't run JavaScript, like Discord, etc. We want it to work there and have information and still want to be able to write a nice, simple, single-page application. So basically that's Next.js explained. There's a lot more to that. Next.js has a ton of features for front-end development and also like back-end rendering. But in general, it doesn't have any sort of back-end purposes or features. It doesn't have any built-in authentication or any built-in ORM or something like that. You need to combine all that yourself, which we're doing here with Prisma, for example. So the final piece in this schema that we haven't talked about yet is Pixi. So there we have had a lot of discussions about that, about how we render the actual game. For example, the prototype that Javi made, I think is just similarly to Advanced Boss by Web, it just uses HTML elements. Yeah, I could go into detail about why and how, but basically pixi.js looks better, is a little bit harder to program, but also performs a lot better because it's like basically meant to do this sort of thing that we are doing. And also, if we didn't use pixi.js and instead used normal elements, like HTML elements basically, then we could also get into issues with interactivity because when you have normal HTML elements, the browser tries to do a whole sort of features for accessibility, for example, or being able to provide zooming and selection on mobile, for example. And all of those things can mess up and create issues. So with pixi.js, when we have our own rendering, basically engine, then we don't have to deal with any of that, and it only has the features that we tell it to have. So yeah, pixi.js is basically a little bit, I wouldn't really call it low level, because it just uses a different API to render stuff, which is completely unrelated to all of the DOM stuff. So basically, and with DOM, I basically mean what browser and web pages usually consist of. Yeah, when writing the actual rendering logic, basically no HTML is involved, and no sort of HTML or CSS is involved. It's all just it's kind of like a game. It's kind of like if you take a game engine and you take out all of the parts that are related to game logic, physics, cameras, I guess. What else? File loading, all of that stuff. You basically throw away, and what is left is just the rendering engine. And pixi.js, I guess if you really wanted to, you could put pixi.js into the same category as something like Unreal Engine or Unity, though I guess those are more like fully integrated game development platforms with game engines, etc. But just to give an idea on how this works and where this piece fits in. So pixi.js, this rendering stuff, there's no reason and no use for doing any of that stuff on the backend. For server-side rendering, none of that is really needed. If we want to create like previews, we would probably use some other technology and not pixi.js, because pixi.js relies on having a browser to be able to render. I don't think we can even do that on this side. So if you wanted to generate previews for maps, for example, we would employ some other strategy, maybe like some command line tool to generate bitmaps or something. I don't know. So how do we actually load a match and make it visible? So a client or a player, browser, whatever, comes here, requests goes to our application, and it says, okay, give me this match. I want to see this match. So the first thing that we do is first we need to send back a document. That would be like the first thing. A page is freshly loaded. Once the page is open, we don't need to load any documents anymore, any HTML. Then we can just communicate with JSON. So where would this example land? Where would this request land? So at first it would go to next.js, because next.js is like the top piece for everything except API calls, direct API calls. And when the client goes here, it doesn't know anything about an API. It just wants a web page. So it goes to next.js. Next.js checks, okay, maybe I want to server-side render some stuff. So for this match, like a title or a preview image or something. So it goes to tRPC, it goes over here, goes to our logic to load some stuff, goes to the database, maybe fetches a title, and then goes all the way back here, generates some HTML, and then sends that HTML down here. And this HTML contains some of the server-side rendered information, as well as the links to the script tags with the links to the JavaScript for our code for this route. So even though we generally write a single page application, Next.js already like does some code splitting, so we don't load all of the code for the entire application for any request. We only load the stuff that we probably need. And so then the client is busy for a little bit of time because it needs to download the JavaScript, which basically goes like this route, just goes to Next.js and back like here. And when it has loaded the JavaScript, it will start to process that. And then in the JavaScript, at some point, it will have instructions to load some data from the API in order to load the true match state, like the thing that you can see, which we need before we can start to render, obviously. So it goes basically this route. It goes to tRPC because it's an API request, because basically now the client has become sentient. It knows stuff about our application because we gave it instructions on how this stuff works. So it goes to tRPC and maybe says, okay, please give me the information about this match. So it's not requesting just a document like every browser that doesn't know what's happening, what's going on. It asks for specific match information from our API. So we go to our server state. Maybe we don't even need to go to the database because we have it in memory, and we send back the information that the client wants. So we send it back. And then now the client has all of the stuff. It also, because it has loaded JavaScript from here, it has loaded our pixi rendering code. So the stuff that we write in order to render the game. And now it can use this code that it has loaded with the information that it has fetched through the API in order to render the game. And that's basically the entire loop of how the frontend works. I say just basically after like talking for, I don't know how long. But yeah, so that would be like a full request going from 0 to match rendered. And then for every subsequent changes, the client creates a WebSocket connection to tRPC, which it already had that open before the first API request. But basically, after it's loading the JavaScript, it will then process the JavaScript, and the JavaScript will tell the client to create a WebSocket connection to our server, and then fetch data and also subscribe to events. And that's the important part, because when it subscribes to events for these matches, then our server, whenever an event gets submitted from a different client, we process it here and we send it back to all of the clients, and then they can use our front end and Pixi code to then do the according changes in the game visually. Okay. I gotta drink something again. My mouth is getting dry. I know that's a lot. How about any questions?
With regards to front and back end, usually, like, since we talked about like the database and things like that earlier, it will start from the back end first, right? And then it just goes, well, the front end, the client will request something from the back end, and the back end gets initialized, and then it just renders everything. Is that correct? So basically everything you see starts from the back end.
Well, I guess that would just be my way to explain it, because going the other way around assumes knowing about some things that happen later on. That's just because I start with the backend. For me, from at least my way of thinking, it's always easiest to start with the data. Because the data is the thing that we want to keep as small as possible, and that we have the most knowledge about what we need to store, for example. All of the requirements about our application, like being able to have previews, that's what defines what data we need to store. And that's why I explain it in this way, going from backend to frontend. I don't know. That's just the way I think. But it doesn't really have anything to do with in what order code is executed. Because obviously nothing happens unless a user visits our website. That's obviously always the first thing that happens. The only exception to that is whenever another user performs an action and it gets broadcasts to everyone else. That's the only exception where the server starts doing something. But to be honest, that's also only because of a different user. So it's just a matter of perspective. You can always start at the user, because without users, our app is useless. There's nothing happening. That should be pretty obvious, because we don't have any time. Okay, there's one exception, and that's timeouts, I guess. So when your time is over from your clock, then the server is actually doing something without any player being involved. That's the only exception. Otherwise, everything is completely user initialized, I guess you could say. It's just that some users are observers in certain situations because it's not their turn, for example.
Okay.
I hope I could answer that reasonably. I'm not sure.
No, I think you answered it. Yeah, I think you answered it already. Yeah.
Okay, cool. Any other questions? I know this is a lot, so feel free even to ask more fundamental questions. That's why we're here.
Oh, so with regards to the code base, that's talking about like what we have existing right now.
Yes.
Currently, okay.
And basically everything that I've shown, with just one or two exceptions, for example, the file system part, that's already basically in the code. And we can also see that. And I hope that all these beforehand explanations help understanding the code when I show it in a second. Because I think this helps, because if I would just jump right into the code, I think it would be too overwhelming, even though this is already overwhelming, maybe. I don't know. Of course, it's hard for me to judge, because I've been doing stuff like this for a couple of years. So, yeah. All right.
No, I think it's. Oh no, I was gonna say I think it's all right to start with an overview first before looking into the code.
All right. Cool. So unless there are any other questions or anything like that, or comments, then we're just gonna show the code a little bit. And I think probably only up to 1 more hour. Last time we also did 3 hours, and I don't want to do it any longer than last time. Because I think we will just all get exhausted and kind of shut off and not really pay attention, etc. And also my language will get very sloppy. All right. Okay. So no more questions. No one is unmuting. So let's jump into the code next. All right, let me quickly check recording. Okay, recording seems still fine. And let me share my screen. All right, now you should see my code editor. So, I think last time I spent a little too much time on like the smaller files without going into the actual code, but we still gonna go through it a little bit. So this is like the latest latest standpoint or version of what's on GitHub, basically in the repository, the main branch. So let's just quickly jump through a couple of files. So here we have some TypeScript configuration, which basically tells TypeScript how strict it should be with the language, some certain configurations about how modules work. That's stuff that hopefully no one has to really deal with a lot, because it should ideally just work. Yeah, normally you should be able to just leave it as it is. Basically, it has instructions for like what are we actually developing? Are we developing a web application? So do we have browser APIs like the DOM? Are we working on a Node application where we have Node modules, for example, like native Node modules? That's where what the purpose of these types of files. And it has some specific settings and configurations because of the different tools that we use. For example, as you can see here, there's some stuff related to PostCSS, some stuff related to Tailwind, some stuff related to next.js. Yeah. So here we have some Tailwind configuration, which is read by Tailwind when it processes classes on the different elements for like colors and stuff like that. It's basically just a config file. There's nothing really specific to the project structure to talk about here. README, we can skip that. Package.json. This is an important file. A package.json for JavaScript projects is most of the time the central file where most of the important technical information is stored about our dependencies, for example. So here we have like some version that's not really all that important except for private true, because we're not writing a package or a library that can be imported. We're writing an application. So that's when you set private to true. And then down here we have like all of the different dependencies. And considering all of the stuff that we already do on a technical level and all the problems that we solved, is actually still a pretty manageable list of dependencies, especially when you consider that a lot of these dependencies are just for our linter. So a linter, the linter that we use, ESLint, helps during development to spot problems in different contexts. Doing stuff in React that you shouldn't do, for example, it will highlight that and will tell us about that. So all of this stuff is basically very, very simple dependencies, and you can ignore it for the most part. They're still important, obviously, but the actual important dependencies for how our application works would be something like TypeScript or Tailwind or Prisma or what else? Basically, most of the stuff in here. Prisma, tRPC with some different modules, because tRPC is very modular. You can, depending on how you use tRPC, you would use different packages. So that's why it's not a single one. Next.js, for example, pixi.js, React, because even when you use Next, you still should provide your own React version. It doesn't basically just do it for you. And also Zod is also important. Actually, probably maybe even the most important one, because otherwise development would be very annoying. I will show an example of Zod. And actually Zod is a very deep topic if you've never seen a schema library or a validator library, I think. But when it clicks, Zod is awesome, and you wouldn't want it any other way. At least when you see how code looks when you don't have something like Zod, and I will show that in a little bit. All right, so what I want to draw your attention on is scripts. And this looks very messy, but scripts are very important, not just to get you help set up, but also it is a way for other developers to give you hints about common tasks that you do during development and what can be done. So scripts are generally just aliases for other commands that you can run. And what are these other commands? Often they are they run programs provided by modules. So these are programs that don't run in deployment. They don't run when the app is running. You can run them in development for different things that you want to do. For example, we have a command here, initialize. This is what you would run when you start when you clone the project for the first time and want to set it up. So what does initialize do? So first it runs npm run db up. So this is basically, it's not recursion, but it basically calls just another command from this list. npm run, this is what npm run does. So to run this, you would run npm run initialize after running npm install, obviously, and then it would run this command. So it would do docker compose upd. So what does that do? Basically, you need to have Docker installed in order to have a very easy way of setting up of creating the database. And this file describes how the database should look like, which version, what port to run on, and some other stuff. We do it this way because then you don't have to set up as much in terms of passwords and users and all that stuff. You don't need to do it all yourself. Most of it gets done for you by this docker compose YAML file. So it will create the container and stuff. So that's what this does. And then the next command that it runs is prisma db push. So prisma db push, just you can see from the highlighting, it's the same text piece between these two. What it does is it reads the prisma schema that I've mentioned before and writes that to the database. So basically it goes inside of this file. So basically this is our schema that generates both our interfaces that we could use in JavaScript. And with interfaces, I don't mean TypeScript or Java interfaces. I mean, basically JavaScript objects is what they are, but we don't see them. They're hidden from us. We can't access the lower levels. We just interact with them. So this is just a schema file. This is the way that we write basically our tables in Prisma, but it's a little bit smarter than just writing SQL, because in SQL we can't really express true relationships between tables. The best that we can do is create tables and then create foreign keys, and then we just have to stitch the relationships together ourselves with our code. And Prisma does most of that for us. So we have like actual columns, like real columns, like this one, ID, with the type string, and we say that it's the ID. Basically, that just sets the unique flag on SQL. So all of the information in here can generally be mapped to raw SQL. And unfortunately, I know a lot of developers try to kind of tiptoe around SQL and use ORMs to like hide it, but it is an absolute requirement to know at least like some of the fundamentals and basics about SQL to even make web applications with a database at all. So basically this ID annotation says that this column right here should be the unique key, the primary key. And then here we say to Prisma, when we create a new entry, give it some default generated CUID, which is kind of like a UUID. Just as an example, no? All of these other columns should be self-explanatory. They're strings, they're not optional, so they must be specified when creating entries. But this is actually like a sort of fake column. It's not an actual column on the database. You only see the author ID, but what this does is it tells Prisma to treat this column as part of a relationship, and it will create the foreign key, and it will allow us to very easily load the related pieces of data for us. So because of this relationship, we can very easily fetch a post and all of the author information, for example. It's pretty easy to do this way. If we didn't have something like this, like these relationships, what we would have to do is we would have in raw SQL, we would have to write a manual join. And then when we have the join, maybe we have to deduplicate entries because we want to put them into objects, and it just becomes very messy. And that's just how web development works, and that's what Prisma kind of solves for us, or at least helps with. So last time, I think I went through this file in a lot of detail, and I'm probably just going to go to the more important stuff. We have some enums here, and these are not actually stored in the database. They are just basically lists of allowed string values that Prisma is going to allow us to store in the database. So basically it acts as a type of layer in between us and our database, and it will only allow certain strings, even though the database has no idea about which strings are allowed and which aren't. But it doesn't matter. We can just store strings there, and we can say through Prisma that only these certain values are allowed. So, yeah, one of the things that we talked about last time definitely was the differentiation between user and player. So we have users and players in our current system. And the purpose is that we want to disincentivize basically smurfing or alt accounts that will start in the ELO on the like normal rating. And therefore make it so even if you want to create an alt and you don't have any like ulterior motives in terms of smurfing and stomping noobs and stuff like that, you will still start at ELO 800 or something, and have to play against a bunch of weaker players if you're like a grandmaster, and that could be just frustrating for everyone involved. And but also there's like a good reason to have alts in the first place. And that's like obviously something like Grimguy, I guess, is the most known example, where you just want to have a certain player and you don't want to ruin your actual MMR with like a secondary or something like that. So the idea was that we have users, and users are like basically mapped to real people, and then players are kind of like identities or tags, if you want to call them that. I spent a lot of time in the Smash player community, and there you have the concept of tags, like player tags. I don't know how widespread that is in other games. Maybe it's just an esports thing. I don't know. But the point is that some players play under different tags when they play like only a certain character, or when they play a certain style or whatever, or a certain game. They use different names. Sometimes it's just for fun, but other times it's just like a kind of idea. I'm playing different. I'm playing a different game. I'm playing a different character. It's a sort of different identity. It's kind of like going out in different sets of clothes, and then you feel different, you behave different. So that's like kind of the idea. I guess you could replace the name of players with identity or something, but that would just be a naming thing. Neil, you unmuted yourself.
I was wondering, so you just associate user as like the person's profile, and player as in like the user's game record or something like that.
Well, game record would be tied to the player. Users is basically how you sign into WarsWorld, and that's also the level on which we would, for example, ban or moderate on, because obviously if we have some sort of punishment for bad behavior, that goes against players, not against different characters of them that they play, or different players.
Very related question, but will other players be able to tell which tags are by the same person?
I was going to get to that, but that's a very good question that we have also thought of. And the thing is, you can already see in this line right here, secret. And it also has like even a comment there that I made last presentation. So it says secret true means that parent user is hidden on profile. So for someone like Grimguy, that obviously wants to hide their identity, hide their main identity, they would want their Grimguy player to not be publicly visible related to their normal profile. So that's where the idea came from, that we you have a user, and then you have a player, and for each player you can set a secret flag. And when the player is secret, or the player profile is secret, then everyone can see the player, but they can't see what user this belongs to. And if you can't see what user this belongs to, you obviously also can't see what other players this player has. So you wouldn't be able, like if Grim Guy signed up in our application, they have their user and they have their main player, which is Grandmaster, whatever, and they create the Grim Guy alt basically. We would call that a I don't know, like a proper alt, or like a how do we call it? Like a designed alt or something like that, something that we designed is possible to do. And everything else, if you create a new user, that would be like a true alt, which we want to disincentivize because of like the ELO problem that I talked about before. And then they could send set the secret flag on this player, or maybe even on all of their players, and then that would be basically for everyone other than the administrators, which can look into the database. This would be a hidden information, and they can just toggle it on and off how they want. So yeah.
I want to, so I can have my head sort of wrapped around the mental model. So is it real? Can I sort of envision like the user as like a circle, and then the player is like a circle inside user, and you can have a lot of players inside user? Yes,
absolutely. It's a one-to-many relationship. Theoretically, unless we put some sort of limit in our business logic, a user could have as many players as they wanted.
Right, and basically it's just that the user can decide when to use which player that they want in a match, and they can just swap between different players. I meant like Smurf account, and when I meant like swap account, like changing between I want to play an official account versus when I want to play like a Smurf account.
Yeah, I mean, you can kind of imagine it like in Discord, you also have a switch account feature, or if you use Google services or YouTube, you also have a switch account feature, and you should kind of imagine it like that. Like on YouTube, you can create multiple channels, and then you can just create a new channel. But if on one channel you do stupid stuff and write insulting comments or something, then maybe you could ban on your actual account, and then all of the channels are gone. And that would be comparable to the idea we have here.
Yeah, just ban the user and all the player accounts are gone.
Exactly. Yeah. And so obviously a user can swap around players as much as they want, but each player, as you can see here, has an MMR relationship. So every player has their own MMR. So you can't just decide for any match that you have the opportunity to play which player to play in. It has to be valid in the spectrum of MMR that you play. And maybe one of your players is in ELO 1200, so you get hopefully players around that ELO. And you won't be able to play that with your other player that is just maybe ELO 800 because you just, I don't know, are trolling around because you're otherwise very good, and then there you just mess around. You wouldn't get the same opportunities for matches. And also, so obviously, we would have to see how that works when, obviously you can't play against yourself. And we would maybe need, if a user has two players that are similar ELO, maybe we would have to employ some kind of strategy where we only allow a user to search for one game with all of their players, because otherwise you could figure out who is not matching with themselves, and then you could connect them kind of by observing the open matches or something like that.
All right, so this is related to MMR, inflation, ELO inflation. Do you know about the player garbage?
Sorry, come again? What kind of garbage?
No, the player called garbage.
Called garbage?
Yes, in AWBW, there's a player who uses the fact that there's an ELO floor to lose like dozens of matches per day on the global league, and this overall is about as much inflation as the rest of the player base combined over there at WBW. If this player, Garbage, had a 1100 starting MMR for each of these non-true alts, wouldn't he become an order of magnitude more capable of causing inflation, which is one of his goals?
Well, basically, a player is creating a lot of alt accounts to sort of inflate.
Yeah. So is there any plan against a player such as Garbage, whose intention is to inflate elo and who would become 10 times more powerful if they could have an unlimited number of players in their user?
Well, with true alts, you can play against yourself. That's one of the things that our alts, like WarsWorld alts, I'm just going to call them WarsWorld alts, which we won't allow. Obviously, that doesn't make any sense. Why should you play against yourself? And obviously, that doesn't interest any of the players that want to use this feature seriously. So based on that alone, I mean, I guess you could also inflate elo numbers by playing just like ranking down or something. But the thing is that because we have the information in our system, we could adjust how elo works according to how many alts a player has. I don't have a clear-cut answer, but what I know is that because we have this connection in our system, we can take it into account when fine-tuning elo systems or ladders or something like that. And obviously, we can see if someone creates many players. We see the information for our moderators and administrators. We can take action. We can say, you're creating too many players. You're doing something stupid. You're intentionally ruining the experience for everyone else. We're just going to ban you. And that alone would disincentivize them from using the system. So it can't really be abused. From my perspective, this can only have upsides, because if anyone wants to do something nefarious, they would just create true alts. And there's nothing, for the most part, nothing we can do against that, just like advanced wars by web.
I see. I almost forgot that these players would obviously draw a lot of attention. Garbage himself has drawn attention at least a dozen times for this slightly nefarious plan he has.
I mean, it's pretty clear. If they want to ruin the game, and we're not going to give them the tools to make it easier. We're going to try to observe and employ strategies that will prevent that. Maybe having a limit on how many players you can create, or over a certain period of time, or maybe changing how your elo behaves depending on how many players you have, or their elo, whatever, or your MMR ratings. There are many things that we can do, but at the end of the day, if someone does something wrong and it comes out, we ban them. It's pretty easy. And if they want to get around that, they need to create true alts, and there's nothing really we can do against that, unless they basically doing a mistake and then show which alts they have, or post something, and then we ban those, and then they will just come back. It's just, every game has to deal with that, I think. You can do, obviously, like things that other games or platforms do, like IP bans, for example, and then they have to use VPNs. And then you say, okay, but we also ban all of the VPNs, but then you punish users that run on insecure networks and want to use VPNs for their privacy, or because the website is otherwise restricted in their game, because maybe they, in their land, in their country, because maybe their country bans, online games or something like that. It just becomes a whole big topic on what you can do. But in the end, if someone has to resort to true alts, then it's a whole different discussion. This is not really relevant to that anymore. This entire idea of having the split between user and player is to accommodate some of the good-willing players that create true alts for reasons that we can understand. I hope that was at least partially sufficient. But definitely this would probably be a system that many people talk about, and that would probably be drama around it, because obviously it's impossible to get something like this right the first time. But I think we are on a good path, and I only see the only alternative is to only have true alts, and then we're not really better off than Advanced was by web, and we're not accommodating anyone else. And the downside is that when a grandmaster wants to create an alt and they're still pretty good with that alt, even if they just play Grim, then they're going to start at MMR 800, just like anyone else, just as an example, and they're just going to stomp players that are not as good. And so what we can do with players, when you create a player, we can just look at the highest MMR you have out of every player and just like subtract some portion of it, like maybe like a couple of percent, or maybe a fixed set of points or something like that. We can just go a little bit lower. So because if you create an alt, your alt, like an Advanced was alt, your Advanced was alt will probably not be your new main or your new best account. So obviously it doesn't make any sense and would be exploitable if we gave it a higher MMR. But also we don't want to give it the same MMR. Because you're probably gonna play a specific play style on that account. So we're just going a little bit lower, but not too much that you are starting to face a lot worse players. And I think that when we find the right value or the right percentage to handle this, or the right function to kind of calculate it, I think we can have a pretty good experience where good players, when they create alts, will play against, depending on what kind of playstyle they choose, against stronger or weaker opponents, but it won't be as unfair, quote unquote, as with true alts.
I think the answer is very sufficient. It is indeed not too relevant. I was not being entirely serious. Sorry before about mentioning this player who has that kind of tan. And
sorry if I didn't pick up on any sarcasm or something like that, but I don't know.
Yes, I'm very dry. You did say there aren't alternatives, but then you mentioned starting at a lower percentage MMR. I think that's an alternative. I've also thought of at least 3 other alternatives in the meanwhile, but it's not really too relevant. Sorry.
Right. Okay. So yeah, player model. They have their own MMR per league, I think is what we do it. I think every league has their own MMR. And yeah, they have a name, a secret, they have a chat messages relationship for every match. All of the relationships need to be mentioned on every model that's involved. So here you can see chat messages, but it's not a like one-to-many relationship between player and chat messages. There's also like the match. It's like split up per match, obviously. And yeah, they can have posts. This is like for the homepage where we have announcements. That's basically what this is for. Yeah, and some preferences that we just store as JSON because there's no need to split it up any further. Some achievements, one of Manx's IDs with a matches relationship, nodes, which is also where also matches are involved because you can have like notepads per match. And then we had like the idea of a clan system, so you can have clans and you can be the owner of a clan, which is something that we have over here. But I'm not going to get into detail that, otherwise we're not going to get anywhere. And then this a bit more interesting again. This is a WarsWorld map. I called it WW map because map is a term that's used very often in programming, and when you try to import maybe something, it could easily be mixed up with other map things that are named map but that are not what you want. So a WarsWorld map specifically is just basically the data of a Advanced Wars map, basically. So it has it has a name, it has tiles, which is just a JSON array, like a 2-dimensional array. It has and this tiles property also has all of the units. This is a system we actually might change where units are stored, but details on that maybe a different time. It has the number of players that this map is suited for, and it has a matches relationship because matches know what map is there being played on, obviously. So that's why we have a back relationship here. What I mean with back relationship is that there's no property here that like match ID, because one map doesn't have one match. So it's obviously a multi-relationship, many-to-many relationship. So that's why it's only like a prisma relationship on this part. And a created date. And that's basically it. And what this does is, I think this renames something. I forgot what this means, but it has something to do with renaming stuff. All right. Yeah, match is also interesting. Matches have a leak type. They have a status, which you can see somewhere here. Yeah, setup, where players can still join and rules can be changed. Playing should be self-explanatory and finished, and then nothing can be changed anymore. Yeah, matches store their map in this map ID string column. So that's where this relationship comes from. We have a player state, which is basically which players have joined, are they ready, which CO have they picked, etc. So that's just a JSON blob. We don't have any more detailed tables, just to keep it a little simpler. There's this chat messages relationship again, which is also dependent not just on match, but also on player. We had this was also a Meng's idea of being able to publish chats if you want to. So actually, yeah, so this would be something that we sent when all of the participants, all of the players of the match basically agree that the chat can be published, and then the chat is public. Yeah, and I'm not going to go, oh yeah, actually events, this is important, obviously. The event list, the entire like big thing on how all of this stuff works. Obviously that's an important relationship. And then we have events here. So events are stored in the database, pretty simple compared to how much variation there are of events. They just get an ID. They have their match relationship, which match they belong to, and then they have their content. And this can be a lot of things, which we might see in a little bit. All right. So yeah, actually, I wanted to just give an overview over the project, but now we actually talked a lot about the schema. Do you have any questions regarding the schema? Or Prisma?
So is the, well, we see event here, but is the state match, the match state part of the schema, or it's separate?
It's not, because the schema only describes stuff that we store on the database. It is generally the most important file, I would say, I guess, because in my opinion, everything starts with data, and this Prisma file describes what kind of data we're storing. So in my opinion, this is the most important file in the entire project, and in any project actually. And like theoretically, we could build this app without a serverMatchState. It would just be very, 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 very hard. So, and probably very, very, very slow. That's even more important. So that's why there's no serverMatchState here. As you saw, we only store events, and all of the serverMatchState stuff is only in memory. So we only see that in our TypeScript code that we'll look on in a sec. Other questions?
Okay.
All right, let's keep on moving. We're not going to talk about migrations or seeding. What else do we have? Oh yeah, jumping back to the package.json, is there anything else? So we covered what this does, basically. Just creates all of the tables and columns for us based on the schema that we just talked about. And then the final thing that it does is runs the seeder, and the seeder basically just creates some example data. That's what seeding does. I'm not going to get into more detail. Just helps you get up and running with development quickly, or if you need to nuke the database, like reset it, which would be this command right here, then you can get back to a working state more easily, because if you just reset, then everything is gone. You have no players, you need to create everything by hand. It's just annoying. So seeding could do something like create players, create a couple of maps, maybe even create a match that's already running and something like that for development purposes. All right. One also a very useful command is Prisma Studio. Prisma Studio is a feature of Prisma which starts like an interactive sort of database client in your browser. So if you run Prisma Studio, browser opens. I'm not going to do it right now because I don't have the database. I don't have Docker and the database set up, so I'm not going to do that right now. But you can look it up online if you want. It's kind of like using other database clients, like for example, the one that I use most of the time otherwise is called Heidi SQL. There's also like dbeaver, and there's some ones that are integrated into VS Code and integrated into other editors and development environments. And Prisma Studio, the cool thing about it is that it doesn't have as many features as some of the other clients, but it adheres to some of the rules that are not directly tied to SQL, but related to Prisma. So, for example, it will only allow you to insert the valid enums, like the valid strings, where other SQL clients, they don't know anything about the Prisma schema. They just see what's on the database. And databases don't have, most of the time, don't have anything like enums. And it's not what we normally use enums like. And so they would just allow you to input any string. Whereas Prisma Studio will only allow you to put in the strings that are actually make sense because we told it in the Prisma schema. And you can also create relationships. It's just a bit more coherent. It has more context. It has more knowledge because it actually takes the schema into consideration. So unless you do something more low level or performance related with like benchmarking queries, then Prisma Studio is probably the only SQL client you need for the most part. And it's very nice and tidy. It looks very cool, or looks very clean, I would rather say. These commands run the different development stuff. So dev.wss, for example, runs the WebSocket server. So that would be only running the backend part. That is for basically, it's basically just I don't have it open right now, but if you imagine the second diagram that I showed you, where the client has this sort of way around next.js that goes directly to tRPC, basically that's what this spins up to make this possible. And then devnext does the next.js part, and then this command right here, you can see it does prisma.db push, so it does an update if you run this. And it also does concurrently run all npm dev commands, so that would be these two. So it runs both of them. You can kind of imagine it's not like super clear cut, but you can sort of imagine it like this starts the backend and this starts the front end. Though technically Next.js also has some backend parts, as I talked about before, so it's not technically 100% correct, but yeah. All right, and everything else we're not going to talk about today. That's something that you can look into and understand when needed. All right, let's stop with that. We have some next config. Let's skip about that. Licensing, all of that stuff. Not too important. These files are important again. Basically, an end file is like sort of like a private data file for developers where you put in any credentials that you need for external APIs or passwords or secrets that you generate. This is important when you start developing on a project, or maybe when you're updating something, updating in terms of putting commits from upstream, which would be basically like updating your local project from the remote project. Maybe then you need to go into your .env file, which this is a template for the example file. This is a template for your normal env. And the env file has basically what we generally call secrets, so like passwords and stuff like that for your database, for example, which you don't commit. And this is ensured by this git ignore, where we say .env is ignored. So unless you try and force it, you won't accidentally commit your env file to the GitHub. All right. So, any questions regarding this? Everything is, as you can see, pretty well documented. It's like a database password, next auth secret. This is for integration with, basically, you need to specify a string here because if we had something like storing passwords, for example, which we don't have currently, then this would ensure that these passwords are properly hashed and sorted, which is like a security concept that is important when you're storing passwords. And everything that you can see, you shouldn't have to edit anything below this line for development. But stuff still needs to be here. But unless you do anything custom, like spin your own database somewhere else, then you would maybe need to edit this string, for example. Any questions regarding this file? Because this would be like important if you wanted to get started on development. I mean,
I have a small question. So for of course, 2 lines on the bottom is talking about Discord. That's probably like way down the line.
Yes.
But I guess the question I have is still way down the line anyways. But so when we get this into production, then we're not using the example anymore. We're just going to use the .env production.
We're never using the example. The example file is never used. It's just a template for local development.
For the .env, right?
Yeah, so the file that gets used is .env. And then actually, yeah, so this env production is also a template file. And so when we deploy the application, we would also copy this file, then enter the super secret password for like actual production database for next.js, etc. Currently, the only difference between these two is that right here it says node env production, and this environment variable is used by many different libraries and tools to change their behavior. For example, next.js or tRPC will, in development, if it's like this, they will log some additional debugging information when an error occurs. But in production, they won't do that in order not to expose any too detailed information about the system and what went wrong to users who could maybe like try to abuse the API or something. So that's like one of the big differences. There's also like differences where Next.js maybe otherwise would create some additional support files to be able to better understand what's happening and maybe what's going wrong during development. Maybe something like it won't minify the code in development so that it's still readable if you go into the browser, into the sources tab. Something like that.
Okay.
All right. Cool. I don't think I'm going to talk about Terraform. That would be kind of like, I didn't write this, someone else did that knows a little bit more about cloud computing, how that stuff works, like AWS. But basically it's like a description file of what node version to run and stuff like that for AWS when we end up using that. But I'm not going to go into detail now. That's not important for development, basically, this deployment here. Public folder. Basically, this public folder, anything you put in here is basically served kind of, how do you pronounce this? Verbatim? I think it's verbatim. It's basically published verbatim to anyone. So this is like public. So if you wanted to create a very simple website, you might maybe install Apache or Nginx. This is like one of the web servers that is out there. And then you would point to a directory and say, publish this directory. Just send it out. And any HTML you put in there and any images and any CSS is accessible as if you were browsing this directory. So all of the information here is like for static files, mostly images, fonts, icons, and all of that is directly accessible, and it's, well, public. That's what the name is for. So there's no authentication checking and stuff like that, none of that, which also keeps processing a little simpler. And yeah, and here we have some graphics for stuff. A lot of this stuff is maybe not fully final yet. Some stuff in here could maybe move around or be named differently. But I think the idea is pretty clear what public does. So we have 50 more minutes. So unfortunately, I can't show you too much of the code, but I'm going to give you a taste. In our source directory, we have a couple of subfolders, and some of them should be pretty self-explanatory. So let's start with server. Server has code that is exclusively server-side. And that is not like a rule, like a technical rule. You could move files around however you want, but you shouldn't. For stuff that is only relevant for the server, it should be kept in server, just to keep it easy. And when you open a file, you know immediately where this file is relevant on which parts. And something sticks out right here because match logic would be something. Right now, it's only stuff that is only relevant to the server. But honestly, something like match logic could also be something that we haven't shared. And actually, we do have a second folder here as outcome match logic, which does have stuff that is shared. But yeah, so this would be match logic that is only relevant for the server, never to the client. As you can see, apply event to match. This would actually, this is logic that is relevant to the client as well. And we talk about that maybe a different time. So for the most part, let's say stuff inside server is only relevant for the server. So we have some stuff that is related to events, some stuff that's related to how serverMatchState works. So for example, here you can see the single line of code that if you had to say what's the most important single line of code in the project, it would probably be this line, because otherwise nothing would work. This is the container, which is a simple map object. Important. This is not a WarsWorld map. It doesn't say WarsWorld map. This is just a JavaScript map, which maps from IDs to backend And so serverMatchState is basically a big thing that contains all of the serverMatchStates, which are individually have this type. And we can look at that in a second. And here we have this rebuildServerState function, which it gets called before anything else starts up backend-wise, where it will get all of the, and here's like the cool thing. Because of Prisma, this is actually, I would say, very readable without even knowing too much about code and how it works. So what do? We have this Prisma client, which needs to get generated. Every time you make a change to the database, you need to regenerate the Prisma client. We also have I can quickly show that, package.json. That would be one of these two. So this also only does it once, and this watches the schema and then automatically regenerates it. So you would run one of these two, and then all of the stuff that's like on here, this dot and all of the methods, they would update according to what you changed in the schema. And so what do we have? What is the purpose of rebuildServerState? What do we want to do? So first, obviously, in order to rebuild our server state, we need to get all of the matches that aren't finished. So we say match, find many, so more than one, where status, not finished. Not finished. This is like the sort of API that Prisma allows us to use. And with API, I mean a programming interface, not in the sense of like a remote server. API is a very flexible term. But this is like the kind of way that Prisma allows us to interact with the data. And then we can also say we don't just want the raw match, like the single row in our database. That's not enough information. We also want the map data, because we need that for the rebuilding process. And we also want all of the events. And that's what we say with these two properties. So with this theoretically single query, actually Prisma does a little bit more in the background, doesn't really matter. But with this single statement, I would say, we basically get all of the data that we need in just these couple of lines. And then what we do is, we go over each match, we loop over it, and for every match, we basically say, okay, generate the initial changeable tiles, which is like the default state of the map. And then we initialize the server state, basically the first step. So that would be like just after you start the match. And then, here's what to do. Apply all events to serverMatchState. So we would need this file, for example, apply event to match. And here we would need all of the different cases handled for building and walking and attacking and ending turns and stuff like that. And then it would go through all of that stuff and then apply all of that to the serverMatchState. And then eventually it's done. And so this would be the initialization for the entire system. Okay. Any questions for the stuff that I've talked about so far?
Depending on how many games that we're going to have posted, will this be like a very heavy part of the initialization? It
could be. We don't know yet. It's only something that time can tell when we actually try this out. But I can already say there are a lot of optimization potentials here that are relatively easy to employ. For example, what are they called? They're not called web workers. They're called service workers, I think. Basically, with Node.js, we can actually do true multi-threading. It just takes a little bit of setup. But when you have a very concentrated piece where you need to process multiple things in parallel as fast as possible, it's manageable. So there we could say, okay, we don't just use our single one thread that we have by default, as is with our JavaScript Node.js applications. We can spin up service workers or web workers or whatever they are called I think they're called worker threads. It doesn't really matter. We can use Node.js multi-threading to accelerate this a lot. Yeah.
I think it's like related to the browser, right?
This is completely unrelated to the browser. This only happens on the server. And actually, the important part is that this rebuildServerState, if we look into our two main functions for our backend, they are actually run first. So before any front-end stuff happens, before next.js starts, it will rebuild the server state. And only when that all is done, when it's all clean, then it will continue. It will create our next.js stuff, which is here, where it's even just preparing the app. It will only do that afterwards. Though, to be fair, we could parallelize this, but it doesn't really matter. So yeah.
So would it be better to have? Well, I guess we need multiple sockets first, right? But wouldn't it be better to have it run in parallel? Because I would rather. Well, maybe there's a player which is just like navigating around the website, but not really going to any of the matches, and basically, but the forces the user have to wait until all the matches loads before they can actually interact with the website.
No. This code right here is only when the server starts, and the server doesn't start on every request. Otherwise, this entire project wouldn't really be possible. I mean, you can see with advanced WarsWorld what happens if you use a language that basically restarts on every request. Doesn't really work out that well.
Okay, so this only starts when you get into like slash your matches or something.
No, it starts when the server starts. We have a server that's running all the time. Imagine it like a game server, right? A game server, you boot it up. You maybe install Minecraft server, for example. You boot it up. Then it does all of the checking. And as long as it's running, it never has to run this code again. Only when you shut it down, when it crashes, when you do an update, that sort of stuff.
I'm sort of trying to wrap my head around, like, when does the server start?
What about the 3 a.m. AWBW maintenance? Would that count as when this happens?
Yeah, for example, yeah. That was a great example.
So I guess it's just like it's not related to the app itself. It's just when the production servers restarts.
Yeah, it's part of the boot sequence basically for our application.
Okay. So...
And only to recover still ongoing matches. I mean, ideally, if we had planned maintenance, we would have like some sort of grace period. Like maybe, let's for example say we do this strategy. I actually don't know about it, but let's say we do the strategy of Advanced WarsWorld Web where we say at 3 a.m. we shut down the server for maintenance. We do some updates. We put it back. We could say maybe like, okay, up until like an hour before, we basically close new matches, so you can't start a new match. And any long-running games that run over weeks, that don't matter. They still continue. So, but we don't have any like live matches or anything, just to basically not ruin any games that are like live matches or live league. So we close matches at 2 a.m. and then most of the server matches that are here will only be long-running games that are still like remaining in here. And then we shut it down, we do our stuff, it boots up, it does this logic, which is not a lot of matches because most of the players have stopped playing because we told them. And then it's going to start back up again and everything is just like before, ideally.
Okay, so it's like it's just like a game server, like server-wide thing. It's like, oh, we're just going to shut down the server for now.
Yes.
And
yes, but it could, like if we had some critical crash or something that interrupted the entire system. Obviously, if we had just errors, they only happen for the individual processing. But if we had something, I don't know, database goes down or there's a bug and or memory runs out or whatever, then the entire thing goes down.
Okay.
Unexpectedly, like unplanned. And this is what this also accounts for. Well, not accounts for explicitly, but we can still recover from that because we're rebuilding server states. It doesn't really matter for what reason we shut down the application or if it crashes, it will recover from that when it boots up.
Right.
The important part is that any actions that you have taken, as soon as the server receives them and process them, the first thing it will do is serve them to the database so they are safe. So anything that happens after that goes wrong for some reason, doesn't really matter, we can recover from it.
Right.
All right.
Yep, I think I get it. I think I get it now.
Okay.
Yeah, because at first I thought it's like each individual game has their own server, but then I'm like, no, that doesn't make sense.
Maybe we will at some point have to do that or something like that with like worker threads, but I'm pushing that off as far into the future as possible because that will add a lot of complexity for development and deployment. And this is already a very complex application. I think everyone agrees, like at least on the schema of like, let's just create a game. So I don't want to add anything to that isn't necessary right now.
Yeah, at the moment, yeah. Okay, no problem.
And for like, I'm pretty sure for like a couple hundred parallel users or parallel matches, it will not break a sweat. At least I hope so. Okay. We just have a couple more minutes. I'm just gonna finish with this folder overview and just show one route to like give you a taste of how the actual like processing loop works. So we have server stuff in here. Schemas is a very important directory. And this is where Zord comes into play, as you can see up here. So Zord is a schema validation library. So we can write schemas, which gives us both an object that we can use to validate data. So we can check, have you sent this specific type of information for like position or unit type? Basically, that's the question that we ask the data that the client sends us, the user. And we can validate it. We can see, does it have the right data types? Does it have the right shape? Because if not, if we don't check anything, our application would quickly crash because someone's playing around with the API. And we don't want that. We want to validate the data that's coming in, that it's the correct shape. So that's what Zord is for. And at the same time, it gives us type information so that for these validations that we write, we don't need to write interfaces or type descriptions as well, because we have it both in one. So as you can see here, action is obviously very interesting. So first I should say, schemas, we only need schemas for things that are user supplied at any stage, because anything that doesn't come from the users, generally we can trust. For example, stuff that comes from our database, we can trust. Things that we load from the file system, generally we can trust because we have control over that. But anything that the user sends us, we don't have control over that because they could send us garbage data. And we don't want that. We want to be able to reject that data. So that's what schemas are for. So we have action schemas. So here we can see a build action schema, for example, is just an object which has the type literal build, and it has a nested inside of it another schema. So schemas can be nested and composed, which is very powerful. So what does a unit type schema looks like? So we jump to this unit. So unit type schema is an enum of unit types. So what does that mean? Enum basically means one of these in this context. So it basically can match multiple other schemas. And here, I'm not proud of this comment. Let's ignore that. But in general, this unit schema, what it describes, as you can see here, is basically a list of valid strings that are allowed. And what strings? It's all of the strings from all of the different units which are allowed. So if we go there, if we look at that, we derive this unit types from creatable unit schema, which is used for building units. I think I should change the name at some point, maybe like buildable unit schema and not creatable unit schema. It's maybe a little bit too confusing. What is creatable unit schema? Let's jump to that. So basically a creatable unit schema is one of these, which is a infantry or mech or recon or APC or any of these. But in addition to what the schema has itself of each of these, they also need to have a player slot and position always. Unfortunately, this can't really be generalized for all of these at once, so that's why it looks a little bit redundant. So what is a creatable infantry schema? It's another schema, so you can see the nesting is real, and the composition. It uses another schema, which is called with no ammo unit stats schema. So what can we derive from that? It's something that doesn't have ammo, but it's something related to a unit, and it has some sort of stats. And it extends that schema and says with type infantry, which is another helper, which just says it has a type property with a literal. So what does all of that mean? That means that in the front end, when I use this code, you wouldn't exactly use it how I'm using it right here. This is just to demonstrate the type safety that we're getting, because in the front end it's actually way easier. You need to do a lot less to get what I'm about to show you. So let's say I want to create a unit. So my unit. And like, imagine we want to create this unit on the front end as an object to then send it to the server at some point when the user clicks something or something, like in the drop down of the units. So the type that I need to use here is z.infer. This is not something that you generally need to do. This is just to showcase this. Creatable infantry schema. And then now it is an object, and TypeScript through I'm using the extension errorlens, which will show me errors directly here, like here in the line. I can already see. Type empty object is missing the following properties from type. And then it has like a type description here. This is a type description, and this is a type description that was inferred from the schema. So it knows that if I want to create an object that is valid to the schema, it must have a type with the literal string infantry and with this stats object. So if I just trigger autocomplete here in VS Code, that's with control space, I can see, okay, I need to have a type property. And what strings can I give? Only infantry, because I said I wanted to create an infantry. So why do we have these types? The purpose of that is that when all of this data has a type, then when the user sends this data, we can differentiate which unit is which. Otherwise, we would have no idea, because we don't know what the user is sending. We need some kind of real string information about what the user is sending. What unit is he trying, or is she trying to create? So that's why these types are always there for pretty much all of the schemas. But we're not done yet. It still says property stats is missing. So we create a stat object, and it needs to have some kind of fuel, and it should have some kind of HP. I guess this is 100. And so now it's valid. So that's pretty cool. And when the types are composed like this, when we go to where all of these are aggregated, so here, creatable unit schema, I can do the same with the aggregated schema. So I can say const my unit. Oops. I can start an object. And now this is pretty cool because, okay, now it's giving me a very big error message because it has aggregated all of the types. So I can now see what kind of autocomplete do I have? What does every creatable unit can have in common? So things might be hideable, or they could have little units. We get all of these because it doesn't know yet what type it is, what unit. So how can we narrow it? How can we get more closer to data that is actually valid and accepted by our backend? We could start with the type. We could say, okay, let's create a stealth, and then it narrows it down, and it only allows us to specify hidden. And actually we must provide hidden, because we should explicitly say if a created stealth bomber is hidden or not. And we need to say what position, what stats. But also, if we do it another way around, if we start by say, okay, it has a loaded unit, and then in here we need to specify like another type. And if you look here, only infantry and mech can be loaded into a unit that has the loaded unit. And that's important. It's loaded unit, not loaded units. That's a different property. So what vehicles do we have? What units do we have that can only have a single unit? If we autocomplete type and put a string here, actually it doesn't really work. I need to finish this before that stuff works. So let's just put infantry here. Let's just complete the stuff here. Oops. Okay. Unfortunately, it doesn't work. It should have narrowed it down to battlecopter. That should be but because the other things don't work, doesn't really matter. Not too important. But basically, it will throw errors and errors until you actually have a correct combination of stuff that actually makes sense. And that is a good thing, that it's very strict about it. So as soon as I use, Battlecopter, am I stupid? Why has no one said anything? Transport copter, obviously. So yeah.
I thought you were gonna use APC.
So when we say transport copter, we get a loaded unit property and position and stats. And for example, if we provide stats, then it can't have any ammo because transport copters don't have ammo. And when we say instead, let's say APC, and we say loaded unit. Actually, let's say lander. Then we don't have loaded unit, we have loaded units, which is not just an object, it's an array. We can put multiple units in there. And actually, they could also have loaded unit because, for example, for the type, this is already narrowed down to all of the units that a lander can accommodate. So, for example, we could put an APC inside, and then which has another unit, and that has type, and that can only be infantry or mech. So you can see from the schema alone, we already have a lot of game logic and business logic kind of offloaded into all of this type information, all of the schema stuff. It's like static rules. We don't need to implement a lot of this in our game logic anymore for like creating maps. We don't need to do any validation if someone has put a tank inside an APC because Zord will reject that for us. Does that make any sense? Do you have any questions?
Sort of like you're building your safety net ahead of time.
Yes, exactly. So schemas, even though they don't have any like explicit knowledge, it's all just descriptions. It's all just descriptions of shapes and data. It already does a lot of things for us. Okay, we're already 10 minutes behind what I had as a target, but here we have front-end stuff. I'm not going to go into detail on that, how that works. It's mostly just generic Next.js. I don't want to call it generic, but it's mostly just related to Next.js. So if you want to learn more about that, I would recommend just watching a Next.js tutorial. And this pages directory must be in this place. There's unfortunately a Next.js restriction. We can't put pages inside of frontend, but pages is related to frontend because this is where Next.js creates all these front-end routes that I've talked about from. So all of these files, with a few exceptions like _app and API, all of these create different pages that you can navigate to. Then we have some chat logic. This is all stuff that is all of these files don't use any APIs that are exclusive to either the browser or the server, and they're intended to be shared. For example, check the rain is obviously something that you would want both on the front end and the back end. For the front end, for where you can move the unit, that you can see where you can move it. Obviously, mountains obstruct tanks, for example. And on the back end, we need that to validate movement. I hope that makes sense. So that's where we can use the same code and ship it to both the server and the client. And this stuff is new. I don't know. Show pathing. I don't know about this, but it's, I think, for the stuff that Harvey wrote. And right. Yeah, I'm not going to talk about that. But let's look at the final thing that I want to show you, and that would be an example route. So in our server, we have routers. So I've talked about backend routing, and basically we have a sort of top-level router. And here you can see the example, like something like the example on the tRPC website, where we have an app router, and then we export the type, and this is our bridge between backend and frontend for our development purpose. So that we get all of the nice autocomplete. And the root router or the app router for tRPC can be composed again. I love composing. So we can split it up into different categories. So we have one router for posts, we have one for match, maps, actions, and users. So let's look at a rather simple one. Let's look at user router. So the user router has just two routes right now. Or I guess technically they're called procedures. So That's like what I talked about, difference between routes and procedures. But they're kind of like the same. You can imagine them to be generally the same. So what does /me do? So /user/me is often in web development a typical route that you use for the current user's own information. So it's a public-based procedure. This is like a template to create procedures. And we will see a lot more of them in other places. It uses some authentication middleware, uses a player without current middleware, whatever that is in detail, doesn't really matter. And then it returns some context. And in this case, it doesn't really matter. It just has some information like what players the current player owns, so that you can switch between them and then create games with that. And you can update preferences. So this is a mutation. So we have in tRPC, we have queries, which is stuff that returns data generally, just returns data and doesn't write anything to the database. At least that's how it's intended to be used. And mutations, which is intended for you to have input data and then write it to the database, for example, and then give a response. So that would be a very easy router. And then we have more complex ones, or at least where there's a lot more logic behind it for actions, obviously. So actions that are like the important part. And here we have an action router and we have a send procedure. So this would be like one of the most important places in the entire app in terms of runtime. So we have like the database, that's very important. The schema is very important. But for runtime, when the code runs, this is like the code that gets runs the most, probably, because it's for every action this code gets run. And here we do like action validation, transforming it to an event, then saving it. So this is like the three steps. At this point, we use our server knowledge or like server match knowledge. We also put in the RNG and stuff like that. We generate the event and then we persist it. We apply it to the server match state and then we send it out to everyone. And here you can see the channel, the subscription where clients can subscribe to a match and then receive all of the events for it. So yeah. All right. Okay. That was a lot. Yeah, match is also pretty important for creating matches and stuff, but I'm not going to go into detail. I think this was more than enough for a start. All right. Any questions for this last part?
So basically, we just talked about like from how all the initial state is generated. So like right before players or users interact with the map, like build units and move units and things like that, right?
Sorry.
Or maybe so basically we just talked about like how the map gets generated with like all the players in place at turn 0.
Well, what kind of generation are we talking about? That's not very specific. I think what you have in mind is something that's front-end related, which we didn't talk about yet. So
like generation of the map, generation of the units on the map, the terrain, and things like that.
They're not.
Those are not covered. They're not covered yet, right?
Yes, they're not covered. And also, you don't really generate a map. We don't need any generation of a map because we just basically send the clients the map. We just send them the data. There's no generation involved, and then they just render it. We don't need to.
Oh, so we have like a statically coded pre-made maps, basically. And
well, the map that players created, and they're stored on the database. And then when someone wants to start a match, they just basically, quote unquote, download the map, and they can start. They can see the map, and we also store the map on our server as part of the serverMatchState. So the map is also stored in memory, and we can use that to do all of our logic for processing moves where players can go and where they can't go.
Okay. All right.
So you can't. You need to. You. I don't want to say you must not, but it's something like that. Writing web applications, even if it's games, is just different from if you were to code a single-player game. In a single-player game, in a game engine, you would actually have something like generate a map, put a mountain in this place, and the mountain is not passable. You need to go around it. But imagine that the mountain in WarsWorld, it doesn't really exist. It's just a piece of information that the client has in order to let the user not make any bad moves or like wrong moves, because the GUI will not let the user draw a path that goes through the mountain with a tank, because that's what we tell it to. But there's no generation involved needed in that. It's rendering the mountain, and then when you click on a unit and you draw the path where the unit needs to go, we just do a check where are mountains, where are like things that this unit can't surpass and where you can't reach. And then when it gets sent to the server, we kind of like do a like similar thing. We look at the map, we look at the data, we say, okay, there's a mountain here, they can't go through that. And if they said that they want to go through that, we reject this action. But there's no physics involved, right? So there's no type of map generation. The only type of map generation would be a map editor that we would have at some point for creating maps.
Okay, so it's like it's an action check on a reference map.
Yeah, kind of.
Yeah.
There's some other stuff. Like obviously there are some tiles that can be changed. For example, pipe seams. If a pipe seam isn't broken yet, you can't pass it, and if it's broken, you can walk through it. So there's some stuff that has dynamic data, and this dynamic data is stored separately from the static map. So the static map contains the information for the let's assume that the map has an unbroken pipe seam. This information inside of the map object never changes because maps never change. If this entire system assumes that the map object never changes once it's been created, once it's been ready for starting games with. If we want to have different versions of maps, we would create a revision system where we have like a group of maps that is basically one map, but it has different versions. And all of these are not changing. So that's static information. It never changes. And so that's why we can use the same map for many different matches and reference it. But for every match, we need to store all of the things that can change, like capturable tiles, like broken pipe seams. All of that stuff is stored per match, obviously, because that can't be changed, obviously. Imagine if we shared that information, if you broke a pipe seam in one match, it would be destroyed in all matches, in theory. So that stuff is stored per match. So that's why when you look on the serverMatchState, I actually forgot to show this. serverMatchState. So this backendMatchState. This is the interface. So this describes the shape of the information that we store in memory. This would be one match. So what does it have? It has an ID, which corresponds to the match ID on the database. It has some rules, and some of the stuff could change around depending on what we need, what requirements we discover. But this seems like a good starting point. We have a status. So this is, as you can see, imported through Prisma because it generated this for us, which is either setup, playing, or finished. I guess finished we would maybe never need, because when it's finished, we probably get rid of it from the server backendMatchState, but that details. We have a reference to the map. So this is basically just one copy of the data that's on the database, but in memory, that we fetched in order to create the match. And then we have a list of changeable tiles. And it's literally what it says. So changeable tiles are specifically catchable tiles, launchable silo tiles. And I think, I don't remember where, maybe this is missing pipe seams. I'm not too sure about that. But generally, changeable tiles would also account for that. So yeah, that's where we start this. So at these, oh, I was sorry, I just got startled because it suddenly started to rain heavily outside. So at the start of a match, when we initialize it, we look at the map, we reference it here when we create this object, and then we analyze the map for any changeable tiles, depending on its type, and we copy them into this changeable tiles thing right here. And so this can change the data inside here, and this cannot. And then we have units, creatable units. So this would also be initialized with any pre-deployed units from the map data. Okay. Does that answer that?
Yeah. I guess I was just missing what the type looks like for the match site, and it all looks like they're already like predefined. Yeah, right. Yeah, that answers it.
Okay. Okay. Well, so yeah, server BackendMatchState. Maybe this is a bad name. Maybe we should come up with a new name as well as like serverMatchState. It's like match and state. It's all this match and state everywhere. But naming things is hard. It's like one of the rules of programming. But yeah, so this is like also a very important and central piece of the entire system. Okay. I actually forgot how we got there. Oh yeah, I was explaining like why the difference between like a game engine and like generating a map and what we do. So it's all like with web, it's all just input and output. And you just, some user sends some data and you want to assist them in creating the right data. So that's what we have tRPC for example, because it will allow us to use this data, these shapes in the front end more easily. And then we process it on the back end, do some stuff, and then return an answer. And it's, yeah, that's pretty much how all networked applications, even games, work generally. All right. Any closing questions or thoughts or comments? Also, I have the chat open live in case you want to write anything. I can see the chat now. I didn't see it before, sorry. Last thing I saw is that they wrote, "I'm toasted."
He was talking about like the very long session.
Yeah. I'm sorry, but I don't really know how to make it any shorter without leaving like massive gaps.
Well, it is a pretty massive code base.
Yeah, so. I mean, it's a massive undertaking. All right, don't worry, got no questions. All right, yeah, I'm gonna do a little bit of slide editing on the thing that I've recorded if the recording is good, and then I'm gonna upload it to YouTube and throw in a couple of chapters so that it's a little easier to find stuff. Okay, then if there's anything else, it's not something you could get. Yeah, it's absolutely not. I mean, I've been doing software development for many years now, so and I also don't understand everything, and so yeah, this is like developing software and making games is not something you can do so hand wavy. It requires a lot of time and learning. All right, then unless anyone else wants to say something, I'm gonna say thank you for participating. Thank you for listening and asking questions. And yeah, that's about it. And I hope that this project will resume at some point. And that will be it. So I'm going to stop my screen share. And I'm also going to stop the recording now.